Hello everyone, my name is Timothy Lee Grant, and so welcome back to another Leetcoding video. And we are going to be doing this one, number 897, increasing order search tree. So I actually attempted to do this problem yesterday, and I was unable to do it, but to be honest, I wasn't actually really trying. I was I burnt out. Burnt out. And at my company, we are releasing a new product right now. So, and I'm writing the software that's going in our product that's going to be shipped out. And so, trying to make sure that there's no bugs in things, trying to make sure, and we haven't had the hardware to test on. So, it's been a whole circus. So, anyways, tired, but I am not going to give up my goal of doing a Leetcode every single day, or at least attempting to do a Leetcode every single day. So we are going to revisit this problem. So this is what I did yesterday. We run it, it doesn't work. Okay, so that doesn't help us. So we need to go reread it, and I think we can try it again. So let's go. Given the root of a binary search tree, so we have the root right here, okay? Rearrange the tree in order so that the leftmost node in the tree is now the root of the tree. So this is going to be the root, and then I'm just going to delete this, like, there. So I want this to be the root right here, the new root, okay? And then I want this root, or this one, to have a right child, which is going to be this one. So in order traversal, that means we go left, go left, go left, then process. So now process, what does process mean? That means this is our like node, okay? Then we come up here and process this one. And in this case, process means attach the previous's the previous is now going to be the parent, and you're going to connect it through the right child. So this is previous right here. Okay, so then I come up here and get previous and put it towards this one's right. Okay. Now, the question that I'm having is, when I'm doing this, I feel like I'm changing the tree itself, though. So, am I just able to dynamically change the tree? Does that, like, mess anything up? So, I'm going to come here and then add a pointer from here to its right. Okay. Then I'm going to come here, add a pointer to its right. Come here. Uh-oh. Darn. So it is a problem. Because I was thinking, if I come here, in order is going to be, now I process this one, right? So I do to its right. And then we lose track of this one. So, right, because, wait, hold on, I'm doing the previous. I come here. I need to think about this. What is it going to be doing? So, I am getting this one right here. Yes, I traverse all the way down. Left, 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 left. Okay. So now I take left and I get the... I want to... Do I go right? Hold on. This one is now... I want... Or do I come up here? Maybe when I come up, that's when I need to process the previous one. I'm trying to figure out when I process this the previous one. Because if I come up, that means I processed both left and right on this node, and therefore I'm allowed to change this node, right? Because it's the parent. So I'm allowed to change this one's right child. So if I come up here, and now I just popped out of the left, right? I just popped out of left, and now I take the one that I just popped out of and add myself as the right child. Does that work? I come up here, I add myself as the right child to 2. Yeah. Then I come down here and I pop up and I add myself as the left child. No, that's not right. I add myself as the right child. That's not going to give me the right answer, because this is going to be 3 goes to 4. So that's not right. Okay. In order traversal. And sorry if this is a low energy kind of video. I'm trying to keep up the energy. Okay, so I start up here. Here is root. In order traversal. What does that mean? That means left, then process, then right. Left, left, process. What does process? So I want to change this one, and I want to put it as, I can't put it as the right though. I can't, because I can't process in the middle, because look here, I have this 3. So I'm changing them dynamically within the tree. Is there a way to, like, what if I just, like, completely don't care about space efficiency and I just double the tree? And then I just create a new one? So, kind of like this. A new tree equals tree node. Can I just go like this? While, and then, I don't know, def traverse, and then node. Okay. If not node, return. Okay. Traverse node, root, return new tree. Okay. No, I don't think that's gonna work, because right now I'm thinking, like, do I want to do root, root right here, or do I want to do like a new tree node? But then if I have a completely new tree, that's not going to be the same thing. I'm not returning back the same thing. I mean, technically, I might be able to trick it if I did like tree node root.val, something like this. If not root return. And what happens if there's no root? I don't know, return none. Does it really say in that case? I don't so let's just see if we can trick Leetcode. Okay, so we initialized a new thing here, and then now I want to traverse all the way left. Okay, so traverse node dot left. Okay, and now I got to the leftmost position, so now I want to add my root, my new tree. Current node. Okay. New tree. Current node here. So I'm passing that value all the way down. Okay. Passing the value all the way down, and then current node dot right is equal to the node that I'm currently at. So that's this node here. Right, so node. Okay, then I'm gonna traverse left. Node dot, or sorry, right. And now when I go right, I want to add myself, this one up here, 3. So that's the new node. So node. And then we just keep doing it. Oh. No. I didn't mean that. Well, that's not right. So okay. Return none. I think I like that though. That's fine. So, in order, post order. It says in order. Maybe the problem is just lying to me. I think it's lying to me. It's not in order, so let's think about our other options. Could be post order. What's post order? That is when we do left, 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 then we do right, 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 and then we process it. So we're gonna go left, 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 left. And then process it, right? Yeah. Process it. So it's going to be 1, 2, 4. 1, 2, 4, 3. I don't like that. That's not right. It does appear to be in order, though, right? Look, it's like 1, 2. So we do the left, and then have 1 and 2 and 3, and then 4, 5, 6, 7, 8, 9. Done. It is in order. So perhaps I was unfairly harsh to this problem in my accusation of it lying to me, when in fact I was simply fooling myself. Okay, so we've determined that it is actually in order, but we have not determined how to actually sort it out, because we can't just rearrange the tree while we're in the active process of climbing the tree. Okay. So I come here. Then I come here. Then I come here. Now, what can I do here? Here. This is my previous. No, this I'm right here, and then my previous is going to be 2, so I just connect previous's right here. And then I go down here, and now 3 is my previous. So I connect 3 to 4. Oh, wait, hold on. I think that this does work. And then now 4 is my previous, and then I come up here, process this, I connect previous, which is 4. That one's right child is now going to be 5, so 4's right child. I think that this actually does work. So I just come here, and I go all the way down, and then once I get to this location here, I put my previous I process it. Okay, so hold on. I think that this is going to work. So def traverse node previous. Okay. If not node return. Now we go left. So traverse node dot left. And what do we want previous? I don't know. We're just going to put X there. I'm not sure. So now we've gotten to here. Okay. And now we want to set previous. So we're going to do, we want to set our previous node dot right. So we're setting our previous dot right is equal to our current node. So node. Okay, then we want to change previous. Previous equals our current node. And then we want to traverse right. Okay, and then X, because we haven't decided that yet. And then I'm going to get the other boilerplate stuff. So traverse on root. And the previous, I don't know what that would be yet. And then return root. Because we're changing it in place, right? So I think that this actually would be none. Because there is no previous. We're going to come down here and then set none dot right. So I need to do kind of like this. If what? If previous, like if we do have a previous, then set its right to be none. If previous is none, then we don't set the right value. Okay. Because it doesn't have a parent to do so. Okay. So then we set previous is now, the new previous is now equal to the current node that I'm on. So I'm going to come all the way down here. Okay, I'm going to come all the way down here. Previous is going to continue to be none, 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 none. I'm going to try to go here, then I'm going to process it. Previous is going to be none, so we don't run anything. And then I say that the new previous is equal to the current node that I'm at, which is 1. And then I try to go right. Okay. And notice this previous and that previous are actually different because we've changed it right here. So I try to go right. Sorry, but then that's none. So then I pop back up. Aye, but then previous, this is different. Yo, what if I just do this? This, previous equals none. Okay, and then I get rid of this. Okay, and then I just say non-local previous. Okay, and then now I can change it. I think that works. Then I don't know. Does it work? I think it. Oh, because I no longer need that previous. Okay, come on. I think that this is going to work, and the reason is because I'm doing this traverse, and I'm coming all the way down, and I keep track of previous, which is now no longer passed in. So I'm just setting that, like, okay, now 1 is going to be my previous. Now I go up to 2, and then I set 2 as the right child of my previous, which is that 1. And then I change previous to be 2. Then I come up here and I process this node, and I take previous, which is 2, and set it to be previous's right child. So 2 is now connected to 3 in the right child relationship. Then I put this as previous. Then I try to come down here. Then I put my previous, put this node as my previous's right child, which is like that, which is already what we see there. And then I set this to be previous. Then I come up here and now 5, and I set previous dot right. Previous is right here, and then right is equal to my current node, which is 5. So 4 is connected to 5, and then we just keep doing that all the way down. I think it's going to work. What do you guys think? Surprised every single time I get that one. Okay, I got it right this I got it this time. Okay, here we go. Let's see if it's correct. I don't like how long that's taking. It normally means an infinite while loop. I'm probably doing something where right here I'm like connecting them in a loop, and then I keep connecting the previous dot right, so I'm adding a new right, and then I'm trying to go right. Does that make sense? Like I'm taking my current node and I'm adding a right to it. I thought I was doing my previous node, but I think what I'm doing is I'm essentially like adding a step in front of me each time I'm going. I think that's what's happening. So, does it like pass anything though? No. I'm gonna look at the photo a little bit. Like, don't know, I'm stumped. And I already searched the answer yesterday, so. It's probably still up here. Is this the answer to the whatever increase 897, yeah. So here's the answer. So what did I do wrong though? In order traversal left. Okay, so I did that. I did this one. No dot left, none. Self dot current. Dot right equals node. So I'm just doing this is the same thing as previous. And I say previous is equal, the previous is right is equal to the current node. And then this one, previous equals node. And then I go right. So is it this one? Is that the only thing I need to do, like node dot? I don't know. Node dot left equals none. No. So anyways, I guess these two answers are different. So just use this one. Yeah, use this one. So anyways, have a good rest of the day. And my name's Timothy Lee Grant. I'll see you guys tomorrow with more Leetcoding. We'll probably not be able to. I don't know if we'll be able to finish it. Anyways, goodbye.